Good morning, everyone. Happy Friday. Today is our last lesson of the week. And if you remember yesterday, I told you that we were going to go through Standard 12 today, okay? So if you want to turn to page 99, we'll get started. We're going to do 12.1, 12.2, and 12.3 today, okay? So let's jump right in. Now, when we're looking at functions, all functions that we look at are going to be either even, odd, or neither, okay? When I say neither, that means neither even nor odd. Classifying functions can give us some information about what the graph looks like, which includes what specific points on that graph would look like, okay? So I've already written some of this in here, okay? So you can just fill it in as we go. Now, a function is even if every number x that's in the domain, the number negative x is also in the domain, okay? So what that means, f of negative x equals f of x, okay? Remember when we're using function notation, we said that this is what we input into the equation, okay? So if f of negative x equals f of x, then you know we have an even function, okay? In addition, if we have an even function, every point x, y on our graph, we also have the point negative x, y on that graph, okay? So if we think about what this means, if we have the point 4, 2 on our graph, then we also know that we would have the point negative 4, 2, okay? So in an even function, f of negative x equals f of x, okay? Also, if we have a point xy, we also have the point negative xy on that graph, okay? So if we think about kind of what that looks like, say I have the point xy right here. I also have the point negative xy, okay? So my point 1, 2, 3, 4, 4, 2 here. I also have the point negative 4, 2 right here, okay? If I have the point 3, 1, oh sorry, that's 2, 1, 2, 1, I also have the point negative 2, 1. Okay, you might be noticing something about this. For every point xy that I have, I also have negative xy, okay? Which shows us that an even function is even if we have symmetry, symmetry in respect to our y-axis, okay? So if we have a function that's symmetrical along the y-axis, meaning, well, let's say I have, let's forget about these two. So I have this point right here, it goes like this, goes like this. We're pretending that this is more to scale, and we can see that we have a parabola here. For every point xy, we have negative xy. Okay, so we see that this is symmetrical across our y-axis. Okay, that's one way that we can look at the graph and tell is if it's symmetrical across that y-axis. Okay, now an odd function. A function is odd if for every number x in the domain, the number negative x is also in the domain. And, okay, so we see that that's the same. Every x, for both of these, every x in the domain also has a negative x in the domain. However, for an odd function, the function f of negative x equals negative f of x. We're going to see this when we start doing some solving, okay? So f of negative x, when we input a negative x, that's going to be equal to negative f of x, all right? We'll go from there. So for every odd function, when we graph it, if it has the point xy on the graph, it also has the point negative x, negative y. In this case, that means that if I have the point 4, 2 on an odd graph, on the graph of an odd function, then I have the point -4, -2. Okay, so let's think about what that means. So if I have my graph, I have the point 4, 2, which is right here. I also have the point -4, -2. Okay. If I have the point 2, 1, I also have the point -2, -1. Okay. If I have the point 5, 4, I also have the point 5, -4 down here. Okay, so if I were to graph this, each point here corresponds with a point over here. Okay, with our even function, we looked at symmetry related to our y-axis. See, these points fold over to this side. With an odd function, we do also have some symmetry, but in this case, the symmetry that we have for this function is the symmetry related to the origin. Okay, so this graph, the function is odd if the graph is symmetric with respect to the origin. Okay, now what that means is if I take this branch of my function right here and I turn it 180 degrees, so I take this part and I turn it 180 degrees, it's over here. Same points in the same order. Okay, we have this like this, curls this way and goes up. If I turn that 180 degrees, it curves this way and goes down. Okay, so if we're looking at symmetry, an even function has symmetry with respect to our y-axis. An odd function has symmetry with respect to the origin, meaning that if we turn this 180 degrees, we're going to see these points line up. Okay? All right. Now, if we have something that is neither, if we have a function that is neither even nor odd, we will not see any symmetry with respect to the origin. We will not see any symmetry with respect to the y-axis. Okay? So, if we're looking here, okay, we want to think for a second. Looking at this graph, we can think about two things. We can think about the points. Okay, just move that there. We can think about the points and we can think about symmetry. Already I'm looking at this and I see that there's no symmetry related to the y-axis. So I know this is not even. So this function is either odd or it's neither. Okay, so I want to think, if I take this and I turn it 180 degrees, do I have the same thing? Yeah, the answer would be yes. Okay, I can also consider that I have the point 1 1/2, 2, or I could say 3/2, comma 2, and then I have the point -3/2, -2, -3/2, -2. Okay, now this reminds me of this right here. If I have x, y on the graph, I have -x, -y on the graph. Okay, so in this case, this function here is odd. Okay. How about this function here? Now I'm looking at it and I'm thinking, first I'm thinking, is there symmetry related to the y-axis? So if I took this side and folded it over, would it be the same? And the answer would be yes. So what we have here is an even function. Okay. Now let's look at this one. Now this one might be a little bit tricky because looking at the graph, I know that's a parabola, so I know that there's symmetry along my vertex. There's an axis of symmetry there. However, when we were talking about even functions up here, we were talking about symmetry with the y-axis. here's my y-axis. I don't see symmetry there because I have this branch of the parabola here going up and it's going down here. Okay. Now I'm going to look at symmetry through the origin. Okay, so if I have this point here, say I have the point 3/2, 2, I should have a point at negative 3/2, negative 2. No. So this one's actually neither. Okay. Now when I'm looking at these, I'm always going to think about that symmetry first. Do I have symmetry across the y-axis, or do I have symmetry around the origin? So always start there when we're looking at graphs. Okay, take a look at this one. Okay, is that even or odd? Okay, and how about this one? Even or odd? Okay, very good. Now, we're going to move on to looking at some equations, okay? I'm going to rewrite a couple of these rules on the other side. So if we have an even function, then f of negative x equals f of x, okay? If we have an odd function, then f of negative x equals negative f of x. Okay, if we have a function that is neither, then we won't see either of these things. Okay, so in order to figure this out here, what we're going to do, we have this function here, f of x equals this. We're going to take negative x and we're going to substitute negative x into this equation for x. Okay, so now we have negative x squared minus 5. Okay, we're going to solve it. F of negative x. Negative x squared is just x squared minus 5. Agree? Okay, so now let's compare this to this. Here, my f of negative x equals x squared minus 5. Now, f of x at the start was x squared minus 5. So this is the same thing, right? So if we're thinking about this, my f of negative x was the same as f of x from the start here. We can see looking at it, okay? Now, if f of negative x is equal to f of x, look up here, f of negative x is equal to f of x, that means that we have an even function. So this is even. Okay. Now, I want to talk a little bit about end behavior. So we're going to create a table of values here. Negative 2, negative 1, 0, 0, 1, 2. Okay. Negative 2 will be 4 minus 5 is negative 1. 1 minus 5, negative 3, negative 3, negative 1. Okay, so I'm going to graph this now, 0, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 3, 1, 3, 2, 1, 2, negative 2, negative 1. Okay. Okay, so looking at this polynomial function, looking at this function here, we have a parabola. We're going to talk about end behavior, okay? End behavior means what happens at the ends of the function, okay? When we talk about this, we talk about as x approaches infinity, and we talk about as x approaches negative infinity. Okay? Now, what this means is, as my x value gets bigger and bigger, as it gets closer and closer to infinity, okay? So we're thinking about as our x value goes this direction, what's happening to our y value? where is the y value going? It's going towards infinity. So as x approaches infinity, f of x approaches infinity. Okay, so as my x gets closer to infinity, my y also gets closer to infinity. Okay, it's moving in this direction. Okay, now what if we go the other way? As x approaches negative infinity, so that means as my x values get smaller and smaller and smaller, as x approaches negative infinity, what happens to f of x? So look here. X goes this way. F of x continues towards infinity. Okay? This is end behavior. We're looking at, on our function, what is happening at the ends. As my x values get larger, my y value gets larger. As my x value gets smaller, my y value gets larger. Okay? All right, let's take a look at the next one. Okay, we're doing a couple things here. First thing, g of negative x equals negative x cubed minus 1. First thing we're going to do is determine if we have an even or an odd function. Okay, so I've substituted negative x in for x here. Okay, negative x cubed, negative x times negative x is x squared, times negative x is negative x cubed minus 1. Okay, so we want to compare this with this. This is g of x. This is g of negative x. First of all, is g of negative x, is this equal to this? Is this the same? The answer should be no, because this one's positive, this one's negative. Now, that would be if it was even. If it's odd, what we're looking at is that f of negative x being equal to negative f of x. Okay? So, if I'm looking here, negative f of x means that this part is negative, this whole part. Okay? If this is negative, then this would have to change signs as well. Do you agree? So we'd have to have, it would have to be g of negative x equals negative x cubed plus 1. Is that what we see here? No. Then we do not have an odd function. So in this case, it's neither. Okay? So let's look here. Create ourselves a little graph. Okay. Negative 2, negative 1, 0, 1, 2. Okay, negative 2 cubed. Negative 2 is positive 4 times negative 2 is negative 8. Negative 1 ends up with negative 1 minus, whoopsies, minus 1. Negative 8 should be negative 9. So we end up with a negative 1 minus 1, negative 2, 0 minus negative 1. 1 cubed, 1 minus 1 is 0. 2 cubed is 8 minus 1 is 7. Okay, so we have negative 2, 2, 3, 4, 5, 6, 7, 8, negative 9, negative 1, negative 2, 0, negative 1, 1, 0, 2, 7. Okay. Now, thinking about what we know about the graphs, we can see that there's no symmetry on our y-axis here. There's no symmetry around the origin. If this was moved one unit up, then we would have symmetry here, and we'd have an odd function. But in this case, it's 1 unit down, so we don't have symmetry around this origin. Okay, now let's look at the end behavior. So we're trying to determine and talk about what's happening at the ends here. And remember, we want to look at as x, oops, I'm going to write this notation here, as x approaches infinity and as x approaches negative infinity. We're looking at what's happening to g of x. So as x approaches infinity, meaning as my x values are getting bigger, my g of x values are also getting bigger towards positive infinity. So, goodness gracious, you guys. So as x approaches infinity, g of x approaches infinity. Okay? Because it's getting closer to infinity. Now, as x approaches negative infinity, what's happening to my g of x value? G of x is approaching negative infinity. Okay? And that's how we'd write that. All right, next one here. To start us off, we are going to substitute. We want to figure out if this is even or odd. So we're going to substitute h of negative x. Okay, negative x cubed minus, ooh, this is tricky because we have a minus x minus negative x. Okay, so if I multiply this out, we'd still have a negative x cubed here times 5, negative 5x cubed plus x. Okay, so we need to compare these two now. Now, h of negative x, is this the same as h of x? No, so it's not even. Okay, the next one is f of negative x, is it equal to negative f of x? Okay, so what that means is if I took a negative 1 and distributed it here, I'd have negative 5x cubed plus x. That's what I have here. So this is an odd function because my h of negative x is equal to negative f of x, negative h of x. Okay. All right, let's graph this bad boy. X and y. Okay, we'll go negative 2. Ooh, that's going to be way too big. Well, let's just go negative 1, 0, and 1. Okay, negative 1 will give us negative 1 times 5. Negative 5 plus 1 will give us a negative 4. Okay, 0 will give us a 0. And then 1 times 1 times 1 is 1 times 5 is 5 minus 1 is 4. Okay, so we have 0, 0, negative 1, negative 4, and 1, 4. Okay, so we see here we have symmetry around our origin. Okay. Sorry, let me move this just for a second. Okay, we're going to talk end behavior now. We're looking at h of x. Okay, end behavior. What's happening here and here? So, as my x is approaching infinity, h of x is approaching positive infinity as well. As x is approaching negative infinity, h of x is approaching negative infinity. Okay, that's my end behavior. All right, we have one more here. F of x equals the absolute value of x. So f of x, f of negative x equals absolute value of negative x. So f of negative x equals x. Okay. What do we think? Comparing this and this, absolute value of x, no matter what x is, this is just x. So f of negative x is equal to x, f of x is equal to x. So that means that my f of negative x is the same as f of x. Okay, that means that my function is even. Okay. All right, we'll look at x and y. I'll go -2, -1, 0, 1, and 2. Okay, we're looking absolute values, so we have 2, 1, 0, 1, and 2. Pretty simple. Here, 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 here. And these actually end up going like this. So looking at my graph, I can see that I have symmetry over my y-axis, which also proves that it's even. Okay, now let me jot this down. As x approaches infinity, and as x approaches -infinity, my f of x approaches. Okay, so looking at the ends here. As my x value approaches infinity, my f of x value approaches infinity. As x approaches -infinity, f of x approaches infinity still. Okay, and that's end behavior. All right. Okay, well, you should be all set to go. There is the standard 12 practice at the end of the lesson here. So go ahead and take a look at that. I'll answer any questions that you have on Monday, okay? Everybody have a great weekend. See you Monday. Bye.